Good morning 11th class. Today we'll do photoelectric effect. Actually this effect is for explaining that wave have a particle nature. Although we have done Planck quantum theory also for this, okay, but this photoelectric effect also explain the wave particle nature of wave. Okay, now this effect was given by, that one is H. Hertz, or either you can say that whatever is the experiment performed and all these things studied, that was studied by H. Hertz. Okay, now what happens in this effect? Okay, actually this effect is very easy normally, but very important. Now just see, simple. Suppose this one is a metal plate, so simple, the phenomenon of ejection of electron from the surface of a metal when light of a suitable frequency strike on it, that is known as photoelectric effect, and the emitted electrons are called photoelectron. Okay, now simple, I think you know that one is that metal have tendency to lose electron. Okay, now in this case, suppose any metal you can take in which metals are loosely bounded. For example, either you can take cesium, okay, either it's another one, but this one is, okay, you have to take those metal in which electrons are loosely bounded, means generally metals have tendency to lose electron. Now when light of certain frequency, that you can say it's a h nu, okay, strikes on the metal surface, then there is a ejection of electron. This effect is known as photoelectric effect, and these ejected electrons are known as photoelectron. Okay, now actually this one is a simple experimental setup. Your main concern is with this, but now you have to study this photoelectric effect in detail also. Reason, because now MCQs are important. Okay, so you have to study each and everything in detail. Okay, because MCQ and question कहीं से भी पूछे जा सकते हैं. Now just see, actually he performed this to prove this, there is a ejection of electron. Okay, again this one is a experimental setup. Here this one is a metal plate, which one is connected with a battery as well as with ammeter. I think ammeter is generally used to showing what there is of, when if there is a deflection is this ammeter, it means कुछ इससे क्या पास हो रहा है. Okay, that is something is passing from this ammeter, and that one is electron. Something क्या है, that one is electron. So now just see, when he pass light, okay, through this metal surface, तो स्टार्टिंग स्टेज वॉज कि उसने क्या किया, कुछ फ्रीक्वेंसी की लाइट इसमें डाली, तो देयर वॉज नो इजेक्शन ऑफ इलेक्ट्रॉन. उसने क्या करा इसको, इजेक्शन को, दिस वन इज द फ्रीक्वेंसी को उसने क्या करा, और ज़्यादा बढ़ा दिया. ओके, इन दैट केस व्हाट हैपन, ओके, व्हेन ही इंक्रीज दैट फ्रीक्वेंसी, तो एट अ सर्टेन लेवल, okay, that one is after that frequency, that there is a ejection of electron, and this one is a detector. Okay, this side and emitter also there. Just see, so with the help of this उसने क्या देखा कि when a light of sufficient frequency, you can say a suitable frequency, strike on a metal surface, then there is a ejection of electron, and that one is photoelectric effect. Okay, actually that H. Hertz, okay, mainly he studied फॉर टू थिंग्स. जो उसने दो पैरामीटर्स को क्या किया था, उसने ज़्यादा डीपली क्या किया था, स्टडी किया था. दैट वन पैरामीटर इज, दैट वन इज रिगार्डिंग टू फ्रीक्वेंसी, एंड सेकेंड पैरामीटर इज इंटेंसिटी. Okay, one is frequency, one is intensity. Now what's the difference in frequency and intensity? दोनों का काम क्या है मेनली, अगर हम बात करें इनमें डिफरेंस क्या है. Okay, now first thing is, remember that one is, if we are talking about frequency. अच्छा देखो, इसमें बहुत एक जनरल सा एग्जांपल ले सकते हैं टीवी का, कलर टीवी. सिंपल, इन केस ऑफ फ्रीक्वेंसी, व्हेन यू चेंज द कलर, या सिंपल अगर हम क्या करते हैं, कलर लाइट जो भी आपकी होती है, अगर हम रिलेट कर रहे हैं कलर से, ओके, तो इट मीन्स इफ़ देयर इज़ अ चेंज इन कलर, ओके, तो इट मीन्स वी आर चेंजिंग फ्रीक्वेंसी. उसमें क्या चेंज हो रहा है, फ्रीक्वेंसी चेंज होगी है, एंड दैट इज़ रिस्पॉन्सिबल फॉर कलर चेंज. ओके, एंड इफ़ वी आर टॉकिंग अबाउट इंटेंसिटी, okay, so in case of intensity, that intensity is related to brightness. Okay, now brightness, simple, if you increase or decrease the brightness, okay, so it means we are changing the intensity. So simple, frequency is related to color and intensity is related to brightness. Okay, now in this one there are certain important observation in case of photoelectric effect. Okay, first thing is as I told you that at least minimum amount of energy is required to eject the electron. Okay, so just see important observation, and that one is very important point, that is for each metal that certain minimum frequency of light is needed to eject the electron. This is known as threshold frequency, and that is represented by nu naught. Okay, frequency not, it's a threshold frequency, because at least certain minimum frequency is required. इससे नीचे में क्या होगा, electrons eject नहीं होंगे, that already that scientists experimentally proof. Okay, now light of frequency less than nu naught cannot eject electron. Now next thing is, when light of that frequency strike the metal surface, immediately there is a ejection of electron. And remember, there is no no time lag between the striking of light beam and the ejection of electron from the metal surface. This one is a continuous phenomenon. Okay, now kinetic energy of ejected electron is directly proportional to the frequency. Okay, means you can say simple thing, if we increase the frequency, अगर हम frequency को बढ़ा रहे हैं, okay, then kinetic energy also increases. Okay, there is no effect on the you can say that one is ejection of electron. Ejection of electron नहीं बढ़ रहे हैं, but there is क्या कहते हैं, increase in kinetic energy. Only the speed of electron is increases. Okay, so that one is one thing. Okay, it is independent of its intensity. Intensity से कोई फर्क नहीं पड़ रहा, सिर्फ क्या चेंज हो रहा है इसमें, kinetic energy increases. And when we increase intensity, अगर हम इंटेंसिटी को बढ़ा रहे हैं, तो देन व्हाट हैपन इन दैट केस, काइनेटिक एनर्जी रिमेन सेम. ओके, बट देयर इज अ चेंज इन फोटो करंट, मीन्स द नंबर ऑफ इलेक्ट्रॉन इजेक्टेड, दिस वन इज चेंज. ओके, तो इंटेंसिटी चेंज करने पे नंबर ऑफ इलेक्ट्रॉन्स बढ़ रहे हैं, ओके, या चेंज हो रहे हैं. ओके, बट काइनेटिक एनर्जी रिमेन सेम. बट फ्रीक्वेंसी चेंज करने पे काइनेटिक एनर्जी इज इंक्रीजेस, बट फोटो करंट रिमेन सेम. Okay, now just see, number of electron ejected per second depends upon the intensity or brightness of incident radiation. Okay, so all these points are very important. That one is regarding to photoelectric effect. Okay, your main concern is the definition, and these things are required for MCQs. Now next thing is actually that photoelectric effect again explained on the basis of quantum theory also. Okay, now according to that one, simple, it's an explanation of photoelectric effect using quantum theory. Okay, now in this one, simple, according to Einstein, okay, when a photon of energy h nu, simple, photon, you know that we are talking about light. Okay, so this one is frequency h nu strikes a metal surface, so some of its energy that we call, that is threshold energy, some nu naught, is used to remove the electron from the surface, and the remaining energy imparted to ejected electrons as kinetic energy. Okay, that one is simple according to Einstein. So this one is h nu is equal to h nu naught plus kinetic energy. Okay, now you can solve this also. Okay, this one goes that side, instead of kinetic energy you can put half mv square, because kinetic energy is equal to half mv square. Now this h nu naught goes this side, it's a minus. Okay, now h is common, so this one is nu minus nu naught is equal to half mv square. So therefore kinetic energy of ejected electron is, so this one is, okay, ke is equal to h bracket में it's a nu minus nu naught. So this one is a kinetic energy of the ejected electron. Okay, on the basis of this we have numerical also. Okay, the one numerical will solve. Now just see, your first numerical is, that one is, calculate the energy of 1 mole of photons of radiation whose frequency is 5 into 10 to the power 14 hertz. Okay, if you remember, this one is regarding to photon of radiation. Okay, we are talking about energy, so it's E is equal to h nu. We have done Planck quantum theory. Okay, E is equal to h nu, that one is given. H is, you have to learn this value, 6.626 into 10 to the power minus 34 joules second. Okay, nu is given to you, either you can say hertz, either you can say second inverse, both the things are same. Okay, now E is equal to, why I am taking this unit, because here also second is given. Okay, तो उसकी constancy को maintain करें जरा. Okay, now just see, E is equal to this one. Now put values. After this your energy is that is 3.313 into 10 to the power minus 19 joule. Now energy of 1 mole of photon, I think you know, किसी भी चीज़ का अगर हम 1 मोल ले रहे हैं तो 1 मोल ऑफ एटम इज इक्वल टू 6.022 into 10 to the power 23 atom. Now here we are talking about photon, that one is also equal to 6.022 into 10 to the power 23 photon. Okay, and here this one is energy is regarding to 3.31 itna, so this is because this one is photon, energy of photon. Okay, so this is multiplied by 1 mole, that is 6.022 into 10 to the power 23. After solving this, your answer is 199.51 into 10 to the power 3 joule per mole. Okay, now then one question is for you, try. Then a 100-watt bulb emit electromagnetic light of wavelength 400 nanometer. Calculate the number of photons emitted per second by the bulb. Okay, thank you.